In the previous video, I asked you to find a domain for this composite function. And remember, there are lots of ways of visualizing what a function is. So in this case here, we've got a function here. Well, we can imagine a function as being a machine. So here we've got an outer machine, and within this outer machine, there's another inner machine here. So you can imagine this inner machine as being this function here, 1 over x minus 5. So this g of x is the inner machine, and then the outer machine can be the positive root of x. So the domain is what you can put into the machine without any of the machines breaking down. So here it has, if you put, let's say, positive 4 here into this machine, it must work for the inner machine. The inner machine cannot break down, and the outer machine cannot break down. So the domain is what you can put into this whole machine without any of the without this inner machine breaking down, without this machine breaking down. Okay, so the domain is what you can put into the machine without any of the machines breaking down. So here, looking at this, what is the domain for this machine, if you like? Well, if you look at this function here, whenever this bit is 0, whenever this bubble here is 0, then this machine here breaks down. Okay, because if you try and put positive 5 into here, then it will be 5 take away 5, which will be 1 over 0. Then here it will break down. The machine here will break down. So the domain for this function here, you can imagine it as being this 0. So imagine the real number line 0, 1, 2, 3, 4, 5 being here, and then on this side you have minus 1, minus 2, minus 3, minus 4, and so on. Well, the domain for this function here is anything on the real number line. You can select any number on the real number line except from the number 5 itself. Okay, so you can say the domain for this function here is any x belonging to the real number line except from the one element 5 itself. And there are lots of ways of writing this. Some people would use a slash like this. Well, just use a minus. So here it's saying, well, the domain for this function here is anything on this number line except from the one number 5, the one element 5. Okay, and now the domain for this function here, well, remember we are putting this into this thing here. So you can imagine h of x as being the positive root of, remember we are putting this into here. So you can imagine that this as being this. The thing is, for this function to operate properly, this whole thing here cannot be a negative number. Well, looking at this function only, if you look at the graph of square root of x here, so it will look like this. Now let's look at the square root of 4. Well, square root of 4 can be a positive 2 or it can be a negative 2. Now if you were just to have look, if you were just to take the square root of x, which will give you this graph here, if you draw a vertical line, remember a function, if you draw a vertical line, it will only give you one output. In this case, it gives us 2 outputs here. That's why we need to throw away the negative side of the square root of x. That's why, well, in order for us to create a function, we had to throw away the negative side here. That meaning that, well, yeah, if you include the negative side, it will not be a function. So in order for us to create a function, we had to throw away the negative side. So if you look at the graph for this function here, hang on. If you look at the graph for this function here, remember we just threw away the negative version of it. Well, if you look at this graph here, the domain for this can never be a negative number, because if you try and put negative 4 into here, what is the square root of negative 4? Well, you can't do it. If you guess minus 2, then well, minus 2 doesn't actually give you a negative 4, because negative 2 times negative 2, that will give you a positive 4. It doesn't give you negative 4. So my point is that the domain for this function here is any, well, 0 here is anything on the positive side, including the 0, but not negative. So the domain for this function here is x belonging to the real number line, where x is greater or equal to 0. So don't try putting negative 9 into here. What's the square root of negative 9? It just doesn't work. Okay. So well, looking at this function here, this here cannot be it cannot be a negative. It has to be 0 or above. Now, if you remember, because our composite function here, we've got this function here. We are burying this function here into here, meaning that we will have this. We will have this 1 over x minus 5. So this here cannot be a negative number. Looking at this here, for h of x to work properly, this bubble here cannot be a negative. It can be 0 or above, but it cannot be negative. So really, looking at this function here, we need to restrict that. Remember, looking at this function here, it's like us looking at this. Hang on, bear with me. It's like us looking at this, the positive version of this bubble here. Now, in order for this to work properly, this here has to be it cannot be negative. This thing here cannot be negative. So you have to hang on. This thing here cannot be negative. So when you look at this graph here, remember 1 over x. The graph 1 over x looks like this. This thing here cannot be. Hang on, bear with me. This thing here has to be greater or equal to 0. Okay. So we need to we have to somehow restrict this to being greater or equal to 0. Now, if you look at the graph 1 over x, it will look like this. So this is a graph of 1 over x. And remember from our knowledge of transformation, if you have a function f of x, let's call it z of x here. If you have a function z of x equals 1 over x, it will look like this. Now, when you apply this transformation, z of x minus 5, you are shifting this whole graph across in this direction. So your graph of 1 over x minus 5 will look something like this. You will have an asymptote at 5. Okay, and it will look like this. Now, my point here is that if you want this whole thing here to be greater or equal to 0, you have to choose the x to be greater than 5, basically. So what you put into here, x has to be greater than 5 in order for you to have this whole thing to be greater or equal to 0. So my point here is that the domain for this function here, because we are going to bury this within here, we need to restrict x to be greater than 5. So, for example, if you try and put, let's say, the number 2 into this x here, if you try and put 2 into here, if you try and put hang on, at the moment we've got this. If you try and put 2 into here, then you will have 2 take away 5. That will be negative 3. That would be 1 over negative 3. So you can actually move this negative up here, okay, and then you can actually take the negative out here. So it's like you, well, this here is a negative number, so it's like you finding out the square root of negative 1/3, which, well, this is a negative, so, well, it will break down if you try. My point here is that because we are going to put this into here, we need this thing here to be greater than 0, to be greater or equal to 0. But in order for this to be greater or equal to 0, this x here has to be above 5. Okay, it has to be above above 5. So my point is that the domain here, well, remember up here we can have x to be anything belonging to the real number line except from the number 5 itself. And down here we need x to be greater than 5. So here, because we've got a machine buried within a machine here, what we can put into here will be, well, we cannot put the number 5 into this machine, and we cannot put anything below 5 into this machine. So we can, well, looking at the number line, okay, hang on, bear with me. So looking at the domain for this one here, we cannot have we can have anything on this number line except from the one element, the 5. Now looking at the domain for this function here, we cannot have anything, well, we must have greater than 5. Okay, so 5 being here, we can have anything greater than 5. So looking at this here, remember that our machine, we've got a machine buried within a machine. In order for both of these machines to work, you have to satisfy both of these domains here. Meaning that, well, if you choose anything, let's say 2 here, yes, the inner machine will work, but then the outer machine will break down. If you choose if you try and put the number 5 into this machine, yes, it will work on the outer machine, but the inner machine breaks down. So looking at this here, if you try, my point is that if you have the domain looking like this here, 0 and then the 5 here, for the first machine you can select anything except from the number 5 itself. Okay, the bottom machine, you can have any number, but it has to be greater than 5. So in order for both of these machines to work, you well, basically you have to select, looking at this here, if you select, well, the domain for the first one is anything on the real number line except from the number 5. The domain for the second one is anything greater than 5. So the domain that will work for both machines will be like the intersection of this domain and this domain here. So basically, the domain for this machine will be any number greater than 5. So the domain for this whole thing here will be anything. Well, it could be x belonging to the real number line where x is greater than 5. You see, if you try and put 4 into this machine here, yeah, if you try and put 4 into this machine here, this machine will break down. If you put negative 3 into this machine here, it will break down because this here will break down. If you put the number 5 itself into this machine here, then this thing here breaks down. So basically, you can put any number. Well, if you put 6 into a positive 6 in here, it will work because it will work here and it will also work here, the number 6. So you can put anything greater than 5 into this machine and it will work. So the domain for this composite function here is given by this. Okay.